finding the unknown measure in similar figures using proportion. Recall that proportion is an equation that shows two equivalent ratios, e.g. 4/5 is equals to 12/15, or A/B is equals to C/D. So to note here, just note that a proportion is when you equate two or more ratios or two or more fractions. A similarity statement states similar figures in simples, e.g. triangle DEF is similar to triangle ABC. So written as it is, that is a similarity statement. Now, given two similar figures, how do we find the unknown measure or measures? Using proportion. That's the question to answer. Right, what we need to do, you need to follow the order of the lettering in the similarity statement in order to come up with the desired proportion. Let me explain this in example. Example number 1, you are given the similarity statement. Given that triangle DEF is similar to triangle ABC, find X using proportion. Those are the two given triangles. Now, a solution from the similarity statement, triangle DEF similar to triangle ABC, identify the three pairs of corresponding sides. The first pair, DE corresponds to AB. Why? Because the DE occupies the first two positions, the AB the same, so they correspond. Pair number 2, EF corresponds to BC. EF occupies the last two positions, BC the same, the last two. Therefore, they correspond. Right? Then we go on to the last pair, DF. D is the first letter, F is the last. So DF should correspond also to A and C. That is how you identify corresponding sides. Once that is done, to find X using proportion, we form a proportion between two ratios of two pairs of corresponding sides. So from the three pairs of corresponding sides, you only choose two, right? Because we know from each pair, we come up with a ratio. Like in pair number 1, example, we have the ratio is DE over AB, right? So you can get the other ratio for pair number 2, pair number 3 in the same way. So we are going to choose the two pairs depending on what we want to achieve, right? So as our first ratio, we are going to take it from pair number 1. Why? Because the measures of the sides are known, right? DE is 3, AB is 12. So from there, we are going to come up with a ratio which is known. Then to choose another pair, we then look at where we want to arrive. We want to find X, and X is in the measure of segment BC. Therefore, BC has to be there. At the end, our ratio number 2, we go to pair number 2, where our BC is present. It's because of the fact that X is involved in BC. Now, we now have these two ratios or fractions. From those two ratios, we come up now with the proportion. That's the proportion we want. Equating those two ratios, the result is a proportion. Now, let us go on to check how are we supposed to move forward. So our statement would be, we start by writing the proportion already we have determined, and we have chosen it as informed by the problem we want to solve. From there, we need to substitute the corresponding values in that proportion. That means D is 3, AB is 12, EF is 7, BC is 2x plus 8. And the result is a linear equation. The variable is x. And we need to solve now for x. But to do that, we apply the cross product. 3 will multiply this denominator, and 7 will multiply this denominator, right? That is cross products for you. When you have done that, we apply algebra, removing the brackets the way we know. Then from there, group like terms. And at the end, we divide by 6, expression number 6, to eventually get our x is equals to 10. So basically, this is the approach. Remember, in two similar figures, right, triangles in this case, we are going to come up with 3 pairs of corresponding sides. But when we want to formulate a proportion to solve an unknown, you only work with the 2, not the 3 of them. You have to choose from the 3 ratios of corresponding sides, looking at the problem that you wanted to solve. Let us look at another problem. You'll be given a similar figures and the scale factor. We have to note that the ratio that you get when you divide corresponding side lengths of similar figures is called the scale factor, right? And that scale factor is a multiplier, right? So, looking at the given problem, given that the polygon pair is similar and the scale factor of left to right is 6:5, find x. Those are the 2 polygons. X is the side given, and on the other polygon, 20 is given. And in this case, that means x corresponds to 20. We know the fact that they are similar. We can actually find the ratio of those 2 corresponding sides. But once we have that ratio is the scale factor. So I'm saying the fact that the polygon pair is similar means the ratio of each pair of corresponding sides is 6/5, the given scale factor in our problem. So that if I find the ratio x/20, that should be equal to 6/5. Right. This is exactly the statement I wrote in 1. The ratio of x/20 of the 2 corresponding sides is the same as the scale factor, because we know that ratio of corresponding sides equals scale factor. We then apply cross products and then solve for x, and you get that our x is equals to 24. Now, again, what to pick here is from the corresponding sides, you come up with different ratios, isn't it? But what you should know is once you are given figures and you are told that they are similar, we are simply saying the corresponding sides are in a given ratio. And that given ratio is the scale factor. So the relationship between scale factor and the ratio of corresponding sides is just the same, right? As you have seen when we are solving this problem. I think with that, I end here.